G'day again. Today we're going to look at integration. So the first thing is, what is integration? Well, integration is where you change the format of this equation and you're trying to find the area under the curve. So if I try and find the area under this curve, it's between the x-axis and the curve. So let's say I want that area there. And let's say that number was 2. I would integrate that equation between 0 and 2, and that would tell me the area under the curve. You don't tend to apply integration to lines, although you can, because you're learning to do areas of lines. So if you look at some area which is like that, you would tend to see the area under the curve if that was 2 and this was y equals x. We'll just go x plus 1. You want the area under that curve, or under that line, sorry, it should be a straight line. You want the area there, you're going to tend to find that as a trapezium. It will still work if you integrate it, but it's not normal that you do that. This is standard practice, and this is typically that you'd find it with, by the area of some sort of shape, but it's equally applicable. So let's look at this, and let's look at doing an integration. So if we integrate x squared plus 1 dx, so this is saying we're integrating this equation about x, okay, with respect to x. So what integration says is I'm going to raise this to a power and put the new power underneath. So this is going to be x to the 3 over 3. And this, I'm going to raise this to a power of x. So this is going to become plus x. Now if there's no numbers there, your answer is going to be plus c. If I put numbers there, I'm trying to find an answer. If there's no numbers there, I'm trying to find an equation. So the answer to this would be that, whereas the answer to, let's do another one, x squared plus 1 dx, and let's do this between 0 and 2. Let's actually find out what this is. This is going to give us an answer, some sort of number that tells us this area. This will give you the formula of an area, and you can then nominate where the area is. You might say you want the area between 2 and 4, or wherever you want it to be. Okay? I mean, you might want it between -2 and 2. You might want that area. It's all up to what numbers you put there. So, or what numbers the question puts there, more likely. So if we integrate this, we know we're going to get that response to start with, except there's no c. We're just going to get this bit. We're just going to get x cubed on 3 plus x. And the reason there's no c is we know where we're integrating. So now you're going to substitute in those one at a time. And we're going to do this, take away this. So it's going to equal 2 cubed over 3 plus 2 minus 0 cubed over 3 plus 0. So in this case, that whole thing 0, and this is your answer, 8 over 3 plus 2. So that would be your answer. Well, what is, so if we write that just up there, 8 over 3 plus 2, well, 8 over 3 is 2 2/3, so that's going to equal 4 2/3 units squared. Okay, and you're done. G'day, back again. So now you know what integration is. Let's look at a few examples of integration. They don't necessarily draw the picture for you, they just give you an equation. So let's make up some. Okay, so if we just integrate, and for example, 3x to the 4 plus 7x squared plus 2, well, we'll put a minus in there, shall we? Why not? Minus 2 dx, so I'm integrating with respect to x. I haven't got any numbers, so I'm going to write a plus c. You should have remembered that. So I'm going to get, raise this to a power, the new power underneath, so I'm going to get 3x to the 5 over 5 plus, raise this to a power, new power underneath, I'm going to get 7 over 3 x to the 3. And raise this to a power, because it's a number, it's going to just be x plus c. And that's it. You're done. Okay? So let's do another one. So if we go integrate 4x squared plus 1 on x squared dx. Okay, that's an interesting curve if you want to draw that one. So if you integrate this, what I would do is change this so it's x to a power, and you should know 1 over x squared is x to the power of minus 2. Okay, so I would do this, 4x squared plus x to the minus 2 dx, and now I can apply the rule of raise it to a power, new power underneath. So let's do that. Raise that to a power, and we're going to get 4x cubed over 3 plus raise this to a power. Now this you've got to be careful with, that you don't accidentally write minus 3. Okay, big trick for students there. So minus 2 plus 1 is minus 1, new power underneath is negative 1 plus c. So typically you don't leave that there, you just turn that into a minus. Okay, so you don't do that, you do that. And you can express this like that, examiners are fine with that, or you can express it as equals 4 over 3x cubed minus 1 over x plus c. So that or that, examiners know exactly what you're talking about. And you're done. G'day again, back for part 3. So for this one I'm going to look at some ones where you're given a formula, and you typically have to learn the formula, but it's given in a formula sheet. So for example, integrate cos x dx. So if you integrate cos x dx, it's on your formula sheet, it equals sin x plus c, and again the c is there because there's no numbers there. So this is given on a formula sheet, but if we look at a few alterations to this so that you're aware of what's happening. So let's rub that out and move this x, and let's put 2x there. So what happens to this is you've got a function within a function. Okay? So integrate cos 2x and you still end up with sine 2x plus c. That bit's the same. The difference is you've now got to deal with this. So if this is an integration, you're going to differentiate what's in here, which is 2, put it in front and underneath. So I'm going to get 1/2 sine 2x plus c. Okay? So let's do another one. So if we change this to another recognisable one, you should recognise 6 squared x, and let's change this to 3x, and let's put a 6 there. And we need a dx, don't we, because we're differentiating with respect to x. So if you see anything like this where you've got a number out the front, I would tend to move this straight out the front before you start. So I tend to think of it as 6 multiplied by integrate 6 squared 3x dx. Anytime you've got numbers there, they're just constants. You don't have to do anything with them. They're just numbers. You can just put them straight out the front and then deal with them later. In this example, it's actually quite simple if you've done it a few times, but even so, it's good practice to put it out the front, so you're only focusing on the integral itself. So integrate 6 squared x, and we get tan. Whoops, that's a 6. We get 6. Let's make it a nicer 6. We get 6 tan 3x, but we've got this function within a function, so differentiate this in front underneath, so we end up with 1 over 3, okay, plus c. Now, like I said, 6 over 3 is going to become 2. That's an easy example that you've probably seen many times where you've got a small number there and it's pretty easy to figure out that this will turn into a whole number. It's just more difficult where you get different things. So this practice of doing this is quite helpful. Okay, Let's do another one. So one of the other formulas you get is e to the x. Now you should know that if you integrate e to the x or you differentiate e to the x, you get e to the x. It's one of the rare, well, it's the only formula that you should know is exactly the same either way. Differentiate that, you get that. Integrate that, you get all plus c if there's nothing there. So let's add a few things into it and make that 3x and put a 4 out the front. Okay? So I put a 4 out the front, I'm going to move it out the front to forget about it. So when you integrate e to anything, it stays as e to the anything. So we're going to have 4e to the 3x plus c. However, you've got to differentiate this and put this in front and underneath. Okay? So this will become 1/3. So we'll get 4 over 3 e to the 3x plus c. And you're done. G'day again, back for part 4. So for this one I just want to look at a special example, integrate 1 over x. So let's do what we've done before. Express this as x to a power. So this is going to equal integrate x to the minus 1 dx. And now let's integrate it. Raise it to a power, new power underneath. So we're going to get equals x to the 0, because add 1, new power underneath is 0. Well, anything to the 0 is 1. So that equals 1 over 0 plus c. Can you see a problem with that? I can. It's very difficult to divide by 0. In fact, your calculator won't like it at all. So this is a problem with this integration. And because integration isn't purely just an algebraic expression, it's area under the curve, this works out to log x. Okay, so this doesn't happen, and you've got a formula which says that equals log x plus c. Okay, and that's on your formula sheet. So we'll have a look at that in just a minute. G'day again, back for part 5. So we're going to look at a little harder examples of log. So for this one, if you integrate 5 over 3x, I would pull the 5 and the 3 straight out the front, so you would ignore them. So you would look at 5 over 3, integrate 1 over x dx. Okay, so they're just constants. 5 over 3 is just a constant, doesn't matter. So that would equal 5 over 3 log x plus c. And you're done. Next one. Now, when you're looking at this, these two look a lot more complex than just this, and you can't drag anything out the front. But the rule is, when it gets this complex, if I can differentiate the bottom to get the top, then the answer is log bottom. Okay, so can I differentiate this? Yes, I get 2x plus 1. Look at that, it's the top. So the answer is log of the bottom. Plus c. Okay, so fairly straightforward as long as you know the rule. This one's a much harder example, but it's the same rule. You have to realise what cot x is. Okay, so cot, or tan, is sine over tan equals, or tan x is sine x over cos x. So cot x will be cos x over sine x. Okay, so if I differentiate the bottom, what do I get? Differentiate sine x and you get cos x. So it's the same rule as here. So that's going to equal log sine x plus c. And you're done. G'day again, back for one more. Okay, so for this one, this will be a harder example and probably the hardest example you get at 2-unit level. Again, we're going to look at a log, differentiate the bottom to get the top. So if we differentiate the bottom, you're going to get 4x plus 4. So in this sort of question, I would write it as the answer. So I would just change the top to be the answer. So I want 4x plus 4 there. So I'm going to write that straight in. Okay, so I want 2x squared plus 4x dx. And now I know if I differentiate that, I'll get that. So the answer of this integral is log of the bottom. The only thing is I've changed the whole question because I've changed the top. So to get this back to here, what have I got to do? Well, I've got to multiply it by 3 and I've got to divide it by 4. Okay, and that will change this back into 3x plus 3. So if I just have this factor out the front, I can say the answer is going to be 3/4 log of the bottom. So that's going to be 3/4 log of 2x squared plus 4x plus c, and you're done.